11.6 Volumes of pyramids. Essential question, how can you find the volume of a pyramid? Look at the relationship between a pyramid and the prism, where both have the same base and the same height. Notice how many pyramids it takes, full pyramids it takes to fill the prism. This should suggest to you that the volume of a pyramid will be 1/3 the volume of a prism with the same base and height. Cavaliere's principle also holds here. As long as the cross sections are the same and the heights are the same, then this volume will have the same as one that's standing straight up. Let's take a look at an example. Here you see I write out the formula. My base is a right triangle, and I write right here, find the area of that base, times by the height, don't forget the third, and there's your answer. Your turn. Stop the screencast and see what you can do. And here is the answer. Number 2 takes a little bit more work because the area is a hexagon. And again, I found the central angle, and once I found the central angle, I was able to find the angle inside the right triangle. This ends up being a 30, 60, 90 triangle, so I know this is the short leg, and then the long leg will be 6√3. Where did I get the number 6? Well, the whole side was 12. That's going to help me find my perimeter, and 12 times 6 will be 72. So this is the area of my base right here. I go to my formula, and I put the area of my base here, which I got over here, and my height 20, multiply everything out, and I get my volume. At this point, let's take a moment to look at surface area. Surface area is, again, creating a net, and in this net we're going to have 4 triangles and a square. Now the base is easy, 10 by 10, but let's take a look at what the information gives us. If the whole side is 10, then from the center to the side, it'll be 5. It'll be halfway across. I already have a 12 being the height of the solid, so I now have a right triangle here, and this is a triple, 5, 12, 13. Now this 13 is important because it's the height of each one of these triangles that is creating the sides of the pyramid. So I am going to take 4 and multiply it to an area of one of the triangles, plus I'm going to find the area of the base, add them all up together, and I will get my area. Notice it says square centimeters, not cubic, because I'm talking about area. Let's go back to volume. This time they're giving us the volume and they want us to find a height. So again, write out the formula, substitute the items that you know, and then solve for what you don't know. Your turn. Go ahead and stop the screencast and see what you can do. And here are the answers. All right, let's take a look at similarity with volumes, very similar that we took a look at similarity with prisms. We use the same formula here. And so the volume of the large or the volume of the small is the scale factor, cubed, because I'm talking about volume. I went ahead and reduced this before I cubed it, and then I went and solved for the unknown. Your turn. Go ahead and stop the screencast and see what you can do. And you should be able to get this answer. Okay, let's find the volume of the composite solid. So this is a solid made up of 2 different solids. One is a cube and one is a square pyramid. So just go ahead and find both volumes, add them up together, and you have the total volume. Your turn. Go ahead and stop the screencast and see what you can do. And here's the answer. Volume of the prism and the volume of the pyramid. Both prism and pyramid had the same base, which was a triangle. So as long as you find the area of that triangle, you should be able to get through the problem.